Presley of ActOutGames.com here, and today we are going to be starting a Doctor Who unit study and making a volcano.
So we are part of a Facebook group called Homeschooling with Netflix, and a nice lady on there came up with a curriculum that is called Traveling Through History with Doctor Who. And I'll put a link in the description to the curriculum that's available for download. And so we started doing that this week. And the first episode is called The Fires of Pompeii. And so we've been doing a lot of Pompeii study.
And actually it happened that when we started the unit study, Fires of Pompeii was the episode we were just about to watch. So it's pretty cool.
Yeah.
Okay, so Doctor Who was actually intended to be an educational historic show in the very beginning, when the first few Doctors were coming out. And what they're supposed to do is they're supposed to travel through a lot of different time periods, the Aztec, the Celtics, a lot of different time periods, but now it's evolved to become a show which is mainly just for entertainment, and now he travels all over time and space, but he still does some historic episodes like Pompeii, and there's one with Queen Victoria. So he definitely
and Shakespeare.
Yep, there's Shakespeare. So there are most definitely some historic episodes in Doctor Who, but he more travels time and space than just time.
So the first lesson that we can talk about is we watched the Pompeii music video by Bastille.
Which obviously wasn't about Pompeii, it was very strange.
And what did you think of the music video?
Well, I just said it was very strange. I don't even know what it's about. It looks like something that would happen in Doctor Who, like these people are infected with a disease or something that makes all their eyes black. It's just very confusing, and I have no idea what's going on throughout the whole thing.
Yeah, we watched it several times and we couldn't quite figure it out. But it was interesting to read. What they said is that Bastille just wrote the lyrics to be what they think somebody living in Pompeii would have said at the time.
Yes. Except the music video, I don't even know.
Yeah, the music video was a little weird. Okay, the next thing that we did was some map work. So we mapped out Italy and surrounding places. You want to talk about it?
Well, what I did is I printed out this thing from Italy, which was fun, but it was kind of time-consuming at the end because we had to answer all these questions. And of course, I don't know much about geography, so we had to resort to Google for this. But I colored in the seas blue and labeled everything, which also took a while. And if you physically know me, I absolutely hate to write, so it was kind of tedious for me. But I colored in everything a different color, and it was pretty fun to color, but not to write out and answer questions. It was kind of boring. Through all that, I can actually point out where Pompeii is in a globe or a world map. And Pompeii is right under Rome.
Okay, so then we had some interesting questions to kind of discussion questions. And the first one was, Peter Capaldi, who would become the 12th Doctor, played Lucius in Fires of Pompeii. Who was Lucius and what did he accomplish?
What we know from studying is that Lucius was a banker, and there were little tablets holding bank records, so that's why we knew he was a banker. And he was just a normal guy, citizen of Pompeii, and what is believed is that he survived the volcanic eruption, but later he died from an earthquake.
Okay, and Daddy and I went to Pompeii.
Picture montage.
Before you were born. I don't even remember what year it was. And so I showed you some pictures of Pompeii. Yes. And we watched a really great documentary that I'll put a link in the description to. And
do you want to talk about what it mainly is?
Sure.
So what the documentary is about is trying to find out how the citizens of Pompeii died. So it's been found out that they did not suffocate and they did not die of lava, and the whole documentary is trying to find out how they died. And at the very end, a professional sculptor takes two citizens from Pompeii and actually makes faces for them. And
one was in Herculaneum and one was in Pompeii.
Yes, one was in Herculaneum and one was in Pompeii. And they actually recreated the faces of what they thought people would have looked like way back then. Yeah, like the girl in Bones, which is a TV show. I don't know if it's still running or not, but it is a good TV show. I've watched a few episodes because my dad watches it sometimes. So I just walk in and watch some of the episodes. So it's like, except this was caused by a professional sculptor and not some magic lady who can see what people's faces are.
So what do they now believe the people in Pompeii died from?
Okay, if you want to watch this documentary and find out, do not listen to this. Yet again, spoilers, this is good. So, what they actually died from was extreme heat. And, except some people question this because the clothes are still there, but they actually recreated the heat and the clothes did not get destroyed. The clothes, wrinkles and stuff were still there, so the clothes did not get destroyed and fabric or nothing. So, in Herculaneum, everyone was reduced to skeletons because Herculaneum was closer to Vesuvius than Pompeii was. So in Herculaneum, the heat struck them so hard that it evaporated their skin and their brains exploded. Their skulls exploded and their brains boiled, which was obviously a very not good way to die. And then Pompeii was farther away, so the heat wasn't enough to absorb their clothing or their skin, which preserved them in the way that Pompeii is preserved today.
And so we have some pictures that I showed you from them where they used to believe that because of that one picture that people died of suffocation, but now obviously we know that's not the case.
They died of heat.
And there's the dog picture, which is really sad.
Puppy.
And then we have some pictures of me and Daddy just walking around in Pompeii in the Colosseum.
And then there's some random pretty places. I don't know where they are.
Random pretty places. But we really enjoyed Pompeii. It was really fun.
And I think they've actually been to Lucius's house. I actually don't know, but they could have been to Lucius's house.
Yeah, I'm sure we did. I just don't remember now because it's been a really long time. So the next lesson is to make a volcano. And so it's just one of those simple baking soda and vinegar volcanoes.
Like a classic chemistry experiment. I've done this in school before, except I had absolutely no idea what was going to happen. And so that was probably one of the messiest days at school, probably next to dissecting a frog or a cow's eye, because those were pretty creepy. Did
yours at school explode?
No, mine didn't go up. It just kind of went up like, this is the top of the bottle, and this is how much it went up and it went down, so pretty cool.
So we're gonna do that.
It didn't like shoot way up.
And see what happens when we do it.
Yeah. I hope it doesn't fail.
I do too. And afterwards, I think you and Daddy will sit down and discuss the science behind what's happening.
Okay, so first we're going to make the cone of the baking soda volcano, aka the mixture we're going to put on the outside to make it look like a real volcano. What we're going to do is we're going to be mixing 6 cups flour, 2 cups salt, 4 tablespoons of cooking oil, and 2 cups of water. The resulting mixture is going to be smooth and firm. More water may be added if needed. Now we're going to build the volcano out of this icky, mushy gooiness. Let's get started. And this is very sensory, so it's pretty good. I think we might make just a little bit of this molding to keep and just let me go around. Okay, so what we're pouring in the volcano first is some warmish water, some baking soda, and a little bit of dishwashing detergent. And now, I'm kind of scared. It's gonna erupt. It seems like this. Oh, oh. Mixing it helps a lot. Jesus. Okay, so since we're doing a unit study with Doctor Who, this ties in perfectly with our timeline. Since we're putting Tardi on our timeline whenever a historical event happens on the timeline. So we put one here for Pompeii, and as you can see, it's way before the Mongols over here and Family of Blood. So that's pretty cool. We already have time travel. This episode was before this episode. As we keep watching Doctor Who and keep doing this unit study, we'll be putting a lot of Tardi on the timeline, and I'll be showing you guys.
So, like Mommy said, we always want to take things a little bit further and dig into some of the science behind how some of this stuff works. And so today we're going to dig in a little bit to the chemistry of what's happening with the
Baking soda and vinegar.
The baking soda and vinegar volcano was happening. And so that's not the same thing that's happening inside of a volcano, so you're not really learning about Pompeii or about volcanoes. But one of the things that we always want to do and that we stress a lot is in a unit study, you take one theme. Like right now, it's the Doctor Who Pompeii episode.
The last one we did was Pirates and Assassin's Creed.
Yeah, Assassin's Creed, that's exactly right. The last unit study we did was on Pirates. But you want to take one theme, like the Pompeii, and just dive into as many things as you can, and even if they're sort of loosely tied to that. And sometimes they string together, right? So we watched the Pompeii episode, and you guys talked about Pompeii and learned about the history, and we put a TARDIS on your timeline to show where it was in history compared to the Mongols and other things that we've studied. And then you guys built that baking soda and vinegar volcano. And so now we're going to go from the baking soda and vinegar volcano to a deeper study about how baking soda and vinegar and water react to create what happened when you mix those things together. What happened when you mix those things together?
What happens when you mix those things together? Kaboom.
Kind of kaboom. Not a huge kaboom.
Not a huge
right?
kaboom,
Really
but kind of a kaboom.
A lot of bubbles, really,
yes.
is kind of what happens, right?
It's like if you shake soda.
It's exactly the same as what you say. It's much closer to that than you think, right? And so what we wanted to talk about is thanks to Hank Green and Crash Course Chemistry. We bought this nice little molecular chemistry set, or molecule set for doing chemistry, organic chemistry. So the organic chemistry set comes with a different set of molecules than you would for some of the other sets. So lots of carbons and oxygens and hydrogens, which is almost everything.
Yes, but there of course has to be stand-ins, like this one is a stand-in.
That's going to be a stand-in for today, yeah.
Yes, this
so
blue one
whenever we do study and we talk about molecules, we always like to break the kit out and build them so we can kind of see what they look like. And you start seeing like really amazing similarities. Like actually these are the two that we're about to talk about. And you can see a ton of similarity. Like things are more similar than they are different in a lot of cases. And like I said, carbon and oxygen and hydrogen sort of makes everything up. Double bonds, that's right. Yeah, that's right. So let's start with baking soda. So this is our baking soda molecule. And the interesting thing about this, so this is a stand-in for sodium.
Yes.
This is not supposed to be sodium in the kit.
Nitrogen.
It's nitrogen.
Tetrahedral.
Yeah, so it's sodium in the kit, right? And this bond between this oxygen, or not necessarily between this oxygen, but between these two molecules, like if you take these apart, right? This bond is actually an ionic bond. And what does that mean?
An ionic bond is like one is positive and one's negative. I forgot the terms for that.
Yeah, you're right.
One is positive and one is negative. So if you know anything about magnets, you know that positive and negative things stick together.
Right.
So they're not bonding by sharing anything.
That's right.
They're just sticking together.
The magnetic charge sort of keeps them. So the sodium is positive,
yes,
and the bicarbonate is negative, and they stick together. They form an ionic bond. So what happens to a molecule like this with an ionic bond when you put it in water?
The bond breaks, and this just pops. Not easily in this case, but it pops right off.
Why does the bond break? Why does water break down ionic bonds?
Water is polar, it goes positive and negative.
Water is polar, and so it's sort of the water molecules surround the things and spread them apart a little bit, right? And so for the purposes of what we're doing here with the vinegar and baking soda, this sodium just kind of goes off and is on its own in the water. And
so there's like a lot.
There's a bunch of them, that's right. This happens, of course, millions of times, right? So, and then this bicarbonate molecule we're going to keep because it becomes important in a second, okay? So then we have our vinegar here, right? And vinegar is kind of interesting because when you put it in water, this hydrogen pops loose.
Is that another ion?
It's not an ionic bond. It gets broken apart. It degrades in the water, and the hydrogen pops loose. And the hydrogen pops loose is really interesting because this is a positive hydrogen ion, which is really just a proton. Because remember, you're right. So hydrogen is one proton with one electron floating around, and they balance each other out. Yeah. And if it loses that electron and becomes positively charged, it's really just a proton. But you can also think of a proton as a hydrogen ion, right? So that pops loose, and this let's see, what was this again?
It's like
this acetate ion, which is left over when this pops loose. It's sort of like the sodium for purposes of this, and it floats around and it's in the water, and we don't need to worry about that anymore. But this hydrogen ion and this bicarbonate ion, they connect in the water.
In the place of where the sodium was.
And so now you've made this thing called carbonic acid. Carbonic acid is this cool little molecule. It's really not. But what it is very unstable. Carbonic acid doesn't last very long after it's created. And you'll notice, so what I'm going to do here is I'll put this stuff away.
Strange.
Yeah, it's kind of cool looking, right? I like the way it looks.
It's like a double-headed, like Cerberus.
A little Cerberus thing, yeah. I think it's kind of cool looking.
Yeah.
So I'm going to use just these molecules in the carbonic acid, and I'm going to replace one of the single bonds with a double bond. Though that's all that I'm doing, but just to show that this breaks down into something more familiar, you take one of these oxygens, and the two hydrogens come together. And what do you get there?
H2O.
H2O, other known as? Water. So a little piece of water breaks off. This carbonic acid breaks down into two things. One of them is water. So that just adds to the water that you're already sitting in. And then I'm going to take this oxygen right here. And that's all. I'm just going to replace its single bond with a double bond. So this is how carbonic acid breaks down. Yeah, you get two double bonded oxygens on one carbon. Like that. And what is this called? You remember?
Carbon dioxide?
Carbon dioxide. One carbon, two oxygens. Carbon dioxide. And this is a gas. And so the water is obviously a liquid that comes, but this is a gas. And every time these molecules, you get one vinegar and one baking soda, every time they break down, this carbonic acid forms, and then the carbonic acid breaks down into one water and one little carbon dioxide gas molecule. And then what do those do? They make bubbles.
Yeah.
Right? So the bubbles float up to the top, and the reason that we put the dish soap in there is because it makes, you make the dishwashing soap, you can make like the bubble stuff that you blow bubbles with, right? So it makes the bubbles really good. So the bubbles stick together, and that makes it sort of bubble and form out. But what's happening is millions and millions of times in that bottle, these things are coming together, carbonic acid gets formed, it breaks apart into water and carbon dioxide, and the carbon dioxide makes the gas. And the cool thing about this, so to tie it back to volcanoes, there are a lot of similarities between what happened.
I think carbon dioxide is volcanoes?
Well, not necessarily carbon dioxide, but gas. Yeah, gas. So there's gas bubbles. You've got this molten magma down in the earth, right? And it's forming these gas bubbles. And deep down in the earth, the gas bubbles are under a lot of pressure, so they're kind of small. They're being pushed together. And as it slowly moves up towards the surface, there's less and less pressure.
It gets bigger.
And it gets bigger and bigger. That's right. And bigger, and then as it gets bigger, it needs more space, and so it pushes the lava up more, the magma up more. And all these bubbles are getting bigger, and they're pushing up the tube, and it's getting bigger. And if there's a pressure chamber that's sealed off to where it can't escape, the pressure builds and builds and builds and builds as this stuff is coming up. And then kaboom! Then kaboom. That's a real kaboom, right? That's a big, like a volcanic explosive eruption.
Or like in Hawaii, if the thing's kind of already open.
Yeah, that's right. It just kind of bubbles out lava, right? Yeah. The magma just kind of comes out because the tube's already there. But it's the same thing. These bubbles are coming up and they're getting bigger. And then at the top, they kind of go bloop, they pop. And they're just pushing the lava, and the lava just rolls out of the tubes. In Hawaii, where we saw on the Big Island.
I doubt there was any much lava in the Pompeii eruption. Pompeii eruption was a different kind of eruption, which we will talk about later.
Yeah, or we've already talked about, I'm not sure.
Or we've already talked about.
Let's talk about it now.
We're time travelers.
Let's talk about it right now. How was Pompeii different?
Pompeii is different because in Pompeii, the gas bubbles were on top of the lava, so the lava was rising up, but the gas bubbles on top popped, and then the gas and ash and a lot of stuff just came pouring into Pompeii, and that's what preserves the stuff, is the ash on top of everything. And except that's not how they died, because they died of extreme heat.
Yeah. Kind of like the pyroclastic
Yes,
wave,
pyroclastic current.
Pyroclastic current.
Is more just a bunch of ash and dust. And now I want to sing radioactive.
It's heat, really,
Yes.
right? It's a fast-moving wave of like ash and heat. And so that moves down, like lava just kind of blue, like flows really slowly, but this pyroclastic shock or current just goes really fast.
Yeah.
And then when it hits, what happened to, maybe you talked about the Herculaneum thing, right?
Yes.
Oh, yeah, like how people died, right? Herculaneum was closer.
Herculaneum was closer, so it was so hot that it just tore their skin off, like the Vosternata. I didn't pronounce that right.
Vosternata. Yeah, Vosternata. Yeah, to die back to Doctor Who again. Right? So their brains, so it's sort of the same thing we were just talking about. Their brains got hot because it started making gas and bubbling and pressure and then
boom.
Yeah,
their heads exploded.
Yeah.
Except the head exploding didn't happen in Doctor Who.
Yeah, that part hasn't happened in Doctor Who. The Vosternata just eat all your meat off your bones.
Yes.
Maybe it's a skeleton. Cool. So, again, back to just homeschooling and how we do our homeschooling. These unit studies are really great. Presley's interested in Doctor Who, and obviously very interested. And so, every time we can go on the timeline and talk about what year was Pompeii? You remember?
Oh gosh, no. I haven't.
Where is it out on the timeline?
It's like around 080?
79 AD. 79 AD. So
it's
like relative
close on the
to
timeline.
things. Yeah, it's close to 0, right? So you can put things on the timeline. So that gives us some like historical context. We talk about the science and how baking soda and vinegar react with each other. We look at the maps and show where was this, where is Pompeii and Vesuvius on the map. There's lots of things, culture, politics. Like you just take this one subject that Presley's interested in and you dig in and you do as much study as you can. And it actually turns out to be pretty cool.
Like
the pirate.
One of my favorite studies we've done was a pirate unit study, where I got to learn about Bernoulli. I almost said Archimedes.
Oh, Bernoulli, yeah. Boy, we did a lot of Bernoulli with the pirate unit study. Yeah. That's right. And so, yeah, we were talking about how sailboats work and how you sail upstream. And
Bernoulli.
So we got into our friend Bernoulli.
I learned about Bernoulli in school a really long time ago, but it was with planes.
Planes, same thing.
Yeah, so the air would go and it would split and it would
That's right.
other people.
But when you do experiments and you get hands-on and you make things work, things make a whole lot more sense, right?
Yeah.
So it's really good to attack it from a bunch of different angles. Being able to see these molecules and how things pop off and pop along.
Except they're
they're much smaller.
big.
Yeah, they're really smaller. Cool. So yeah, that's our little brief science dive into what was happening in the baking soda and vinegar volcano.
Yes.
Anything else that we need to cover from a detail standpoint?
No.
You can probably sign off then.
So yeah, thank you guys for watching, and I will see you tomorrow. Bye!
Bye.